Highway, bridge, and airport runway joints call for tough sealants that can withstand excessive horizontal and vertical movement, have good weatherability, are easy to install, have a short downtime, and have a long service life. DOWSIL brand silicone pavement sealants do the job. Our sealants can be installed over a wide temperature range. They can cure upon exposure to moisture in the air, forming a permanently flexible, high elongation silicone rubber seal. Unlike organic-based, pre-formed neoprene or hot and cold-poured sealants, silicone sealants don't crack, crumble, dry out, or become brittle. Our sealants are capable of withstanding 100% extension and 50% compression of the original joint width. They have excellent recovery, which makes them ideal for use in joints that experience a high degree of movement. DOWSIL sealants remain flexible and resilient years after installation. Studies have shown that they have a minimum of 10 years of service life, and some are still working after more than 30 years. Their temperature stability means they do not get brittle in the cold or too soft in hot temperatures. Easy to install, the silicone sealants allow traffic to be back up and running quickly. When using any DOWSIL brand silicone joint sealant, make sure that you are following all safety guidelines, including the use of correct personal protective gear. You must also comply with local, regional, and federal safety guidelines. For each DOWSIL sealant, thoroughly review the Safety Data Sheets, or SDS, before using the product. The SDS are available at consumer.dow.com/construction or by contacting the Dow Technical Information Center at 800-248-2481. Field performance of more than 20 years has proven that DOWSIL 888 silicone joint sealant is weather resistant and able to absorb large amounts of panel movement, all without the use of primers. Our sealant's excellent performance depends on several factors in the field. To get the maximum performance, DOWSIL sealants must be properly installed in joints that are properly designed and prepared. The first step for long-term sealant performance is proper joint design. The correct width and depth of the joint is critical to future effectiveness and the longevity of the sealant. Because DOWSIL 888 silicone joint sealant has 100% extension and 50% compression capabilities, a half-inch sealant joint, for example, can be expected to extend to 1 inch and compress to 1/4 inch. But because pavement expansion in the field may be different than in the lab, we recommend that a safety factor of 2 be calculated into the design. If the total expected movement is a 1/4 inch, the joint width should be a minimum of 1/2 inch. This gives a safety margin to prevent cohesive and adhesive failure should the joint move more than anticipated. Once the joint width has been determined, the depth of the joint can be calculated. The sealant must be recessed a minimum of 3/8 of an inch below the pavement surface for joints less than 1 inch wide. For joints wider than an inch, the sealant should be recessed deep enough to prevent tire contact. The thickness of the sealant bead should be a minimum of a 1/4 inch and a maximum of a 1/2 inch. The backer rod should be approximately 25% larger than the joint width. So for a 1/2 inch wide joint, this adds up as 3/8 of an inch recess, plus a 1/4 inch of sealant, plus a 5/8 inch backer rod, for a total of 1¼ inches. To allow for actual field conditions, an additional 1/8 inch is added, bringing the total depth of the joint to 1 3/8 inches. In some remedial work, up to an additional 1/2 inch may be necessary. For joints that are 1 to 2 inches wide, the maximum bead thickness of the silicone sealant should be a 1/2 inch. Joints are designed so the walls are generally perpendicular to the pavement surface and have a rectangular reservoir. Where field conditions prevent a strictly perpendicular angle, small spalls can be sealed. With a proper joint design, the fieldwork is ready to begin. In new construction, the first step is to green saw the concrete at desired spacing, to allow the concrete to crack at controlled locations. After this, the initial control crack cut is re-sawn to increase its width and to form the joint sealant reservoir. The joint should be immediately washed clean with high-pressure water. The water pressure should be high enough to remove the latents connected with the sawing process. Flushing should be done in one direction only to prevent recontamination of the joint faces as the washing moves from one joint to the next. After the joints have been washed, they need to be thoroughly dry before the next step. Depending on the weather, this may take a few hours or several days. As a rule of thumb, the joint can be considered dry when the concrete is white in color and no water is standing in the bottom of the joint. Once dry, the joints should be abrasive blasted. The abrasive blasting process should be powered by a compressor capable of at least 120 pounds per square inch and 60 cubic feet per minute. Blasting abrasive needs to be directed toward each joint face to make sure it is clean, and should be concentrated on the top inch of the joint faces, where the silicone sealant will need to adhere. The blast nozzle should be no more than 2 inches away from the joint face. An advantage of abrasive blasting is that the joint is being prepared dry, so the next steps can proceed without delay. Because the moisture content of the concrete plays a major role in the cure and adhesion of the silicone sealant, it is recommended that new concrete should cure for at least 7 full days in good drying weather before the sealant is installed. Right before installing the backer rod, the joint and surrounding areas should be blown clean of all dust using compressed air of at least 90 psi. Air compressors must be equipped with traps capable of removing moisture and oil from the compressed air line. Recommended joint preparation for remedial work is similar to new construction. First, the joint size needs to be calculated. Remember, removing old sealant material may widen the joint somewhat. The removal may take different forms, depending on the type of old sealant. For hot and cold applied sealants, the first step is to remove the majority of the sealant. Then, the joint faces should be sawed back to a clean concrete face. To do this, you may have to remove just a few mils of concrete or entirely reface the joint walls. If this sawing process uses water, then the new faces need to be washed to remove all latents. After drying, the joints need to be abrasive blasted and then blown clean as described earlier. On preformed joint material, the seal material should be pulled out if it is still present. Then, the joint faces can be abrasive blasted to remove residual glue that helped hold the preformed material in place. Once this is done, the joint is blown clean with compressed air. After the joints, either new or remedial, have been prepared, they must be checked to make sure they are clean. Gently rub the side of the joint with your finger to check for dust. If you find dust, like chalk dust from a blackboard, then the joint needs to be re-cleaned. In all cases, the joint must be clean and dry before installing the backer rod. The backer rod has 3 major functions. It controls the depth of sealant placement, it prevents 3-sided adhesion, and it supports the sealant when tooling. The backer rod should be 25% larger than the joint width. The only backer rod materials acceptable for use with silicone pavement sealants are those with a skin that will not allow water to absorb into the backer rod, such as closed-cell polyethylene. Others have the potential to hold water, which may result in bond adhesion failure. The backer rod is installed in the joint using a roller device. This roller needs to have guides on the outer edge, so the rod depth is controlled. It may take 2 passes with the roller to force the oversized backer rod to the proper depth. Placement of the backer rod should be done carefully. Sharp or pointed objects should not be used because they will puncture or break the rod. If this happens, outgassing may occur, causing bubbles in the sealant as it cures. The backer rod should be placed deep enough to accommodate the recess and sealant bead size calculated earlier. At the junctions of transverse and longitudinal joints, the backer rod can be cut out in one of the directions before the placement of the second direction. This will provide the proper depth for all of the sealant and reduce material consumption. When the silicone is placed, all silicone intersections need to be tied to a clean, uniform silicone surface. For concrete shoulders, the backer rod and sealant should continue from the mainline pavement to the outside edge of the shoulder. With asphalt shoulders, the backer rod should be terminated at the edge of the mainline concrete. Use sealant to seal the end of the joint and fill the remaining saw cracks. DOWSIL 888 silicone joint sealant does not require primer with Portland cement concrete. So, with the backer rod properly installed in a clean, dry joint, the next step is to place the sealant. In some instances, a second air blast may be needed to blow out debris deposited by wind or traffic moving past. DOWSIL 888 silicone joint sealant should be pumped directly from the original drum or pail. The nozzle should be moved steadily along the joint, pushing the sealant ahead to form a uniform bead and to prevent air from being trapped in the sealant. This pushing motion forces the sealant down against the backer rod and improves the contact of the sealant to the joint walls. The equipment needed to install the sealant can be manually or air power operated. Powered equipment is recommended because of the speed and ease of application. The major pieces of power equipment required for installation are an extrusion pump to transfer the material from the container to the joint and an air compressor capable of delivering air at 60 CFM and 120 PSI. Complete units, including air-powered pump, follower plate, and hoses, are required for pails and for drums. Air-powered extrusion pumps are available in different output capacities. Higher ratio pumps have greater delivering capability. Specific ratios may vary among manufacturers, but a ratio of 35:1 is the minimum capable of delivering a sufficient volume for efficient operation. Regardless of which pump system is chosen, some features are recommended. Because this sealant cures on exposure to atmospheric moisture, the seals, hose connections, and hoses should be selected to prevent or minimize moisture permeation. They must also be able to withstand pumping pressure and resist abrasion on the job site. Teflon-lined hoses are recommended because their low air and moisture permeability will provide long, trouble-free service. Unlined hoses are not recommended because they allow enough moisture permeation for the sealant to cure in the hose and block flow. Blockage may take a few days or several weeks to form, depending upon the hose material, wall thickness, and the temperature and humidity conditions. To prevent premature cure, all seals and packings should be impermeable to moisture, like those made from Teflon and polypropylene. Hose runs should be kept to reasonable lengths to reduce pressure drops. A hose with an inside diameter of 3/4 of an inch is recommended. Smaller hose diameters will work, but they significantly reduce the volume of material available for sealing. This, in turn, can drastically slow the sealant installation. Daily cleanup or a flushing of the Teflon line system is not required. A small plug of sealant may form in the nozzle tip overnight, but this can be removed in the morning and the pump restarted. Wrapping the nozzle tip with aluminum foil or plastic will reduce the quantity of cured sealant in the nozzle. When the equipment and hoses are not used on a regular basis, they should be cleaned by flushing the entire system with a solvent, such as mineral spirits. All solvent residues must be flushed from the hose before sealant is installed in the joint. When installing the sealant, it should fill the joint from the top of the backer rod to slightly below the pavement surface. Immediately, before a skin forms, the sealant must be tooled to force it against the joint face and to recess the bead the required 3/8 of an inch below the top of the joint. This tooling is required because the material is not self-leveling and must be forced against the joint faces to ensure surface wetting and gain maximum adhesion. The tooling step also forms the sealant into the proper shape for optimal performance. Tooling devices come in an array of shapes and sizes. Most commonly used are pieces of hose, or backer rod larger than the one being installed, or a spatula. The best tools are the ones that give the sealant a concave shape and are the most comfortable for the installers to use. Small spalls or difficult joint interfaces can be touched up after tooling if required. The sealant's curing process will be complete in 7 to 21 days, depending on the weather. After the sealant is cured, you may want to spot check to visually and numerically test the sealant's adhesive and cohesive characteristics. Cut the silicone sealant perpendicular to the joint and along the joint walls for about 2 inches. On this cut tab, mark 2 lines, approximately 1 inch apart. Then pull the tab upward at 90 degrees from the pavement. At 450% elongation, or 5.5 inches, there should still be no cohesive or adhesive failures. In addition, this cross-section of this tab should also be examined for thickness of the final bead, shape factor, and width to depth ratio. If desired, this sample can then be completely removed, its location documented, and be kept as a permanent record of quality control. The test can be run as many times as needed and can be used to compare all sealants and job quality. On all of the test sites, as well as any small areas that may need repair, the repairs are quick and simple. Just cut the defect or test patch out so that the clean silicone remains. Then place new silicone in the void left and tool to proper shape. To simplify this repair step, DOWSIL 888 silicone joint sealant is supplied in convenient tubes. The new silicone material will adhere to the clean existing silicone, and within a few weeks you won't be able to distinguish it from the rest of the joint. The bond will be just as strong as the original. The information presented here covers many of the typical situations encountered during sealant installation. For situations not covered by this training, please contact a Dow High Performance Building representative.